Okay guys, so now let's start the hardware work, and these are all the things that you will require in this project. An Arduino Uno board, a breadboard, uh, an LED or any other output device that you might like a motor or DC fan or whatever. The soil moisture sensor, of course, the IC which is required with the soil moisture sensor, a resistor, preferably of say 12 ohm or 16 ohm, and you'll require these connecting wires which are female to female, male to female, and male to male configurations. Also, you will need two of this male to direct open wire to interface the DC motor that we have. If you don't have such kind of wire, you can simply cut off the other end of the male to male wire or male to female wire and make one yourself. So now let's start with the interfacing and how we can make the circuit work. Just as we had seen in the simulation, first we'll need the soil moisture sensor to connect with the IC. So we'll take two female to female wires and connect it to the IC in this 2-pin output, input that we have. So the positioning doesn't matter, you can position it either way. Okay, now that we have got it done, let's interface this IC with the Arduino board. So what you need to do here is take the female to male wire and I think you can see we have 4 markings on this IC which are saying VCC, ground, DO and AO. What they mean is VCC is nothing but the supply voltage, and the ground and the DO/AO are, the ground is 0 volt and the digital output pin is called DO and the analog output pin is called AO. So now that we have the sensor ready, we'll use female to male wires to connect the IC. So first one is VCC, which is 5 volt supply, and we'll interface it on the breadboard. Now breadboard is used to connect the systems which have a lot of wires, just so that you can easily manage without having any cause of say handling the different wires, and there's not much need of you know uh, lot of different wires that you will rather require if you do not short this multiple together. We are adding the ground to the ground interface in the IC. Okay, now that we have done it, we need to of course supply VCC and ground to the breadboard, and so we'll select 5 volt and we'll give it to the, which wire was it again, black wire. Okay, now cool thing about Arduino, the breadboard, is that whenever you supply anything from the Arduino, all these the external two lines are all internally shorted. So for the half the breadboard means for 1 2 3 4 5, for the 5 different parts, all of these are internally shorted, and you can supply anything here and the signal will be passed on throughout this plate. Now we will need the ground, so you can select either of the ground and supply it. Okay, so we are ready. Now let's pass on the signal from the sensor to the Arduino board. So we'll take the digital output as we had coded for the digital signal, and we'll attach it here. Now if you might remember, all of the vertical linings are shorted internally, and so I can take this wire here and attach it to the 7th pin of Arduino Uno. You can really take any pin, and the order doesn't matter. So now we have that. Now we have our system built with the inputs. We can easily track the data using serial monitor, and also we have successfully interfaced the sensor. What we need to do next is see the output. So I mean, we are gathering data, but there should be some visible element in the end. And also, if you want to make this port, then you will need some sort of water control system to water the plant. So what we'll do is take another male to male wire and connect it to the third pin. Now we'll connect it here. Okay, so what we'll do is for right now, let's try with an LED. So I'm using a 12 ohm resistor, and I am using the LED to see the output. Now if you don't know which uh, leg of the LED is anode and which is cathode, a nice trick is to see inside the LED, and I hope that you can see the LED consists of two plates, and the smaller one here is anode. If you might have learned in physics, these two plates work as an what can I say? It is mainly made of silicon chips, so that you can use this p-n junction property to create photons out of electrons. So yeah, so you will connect the anode to the input and the cathode to the ground. So we'll select this, we'll select here. Now remember, the ground is different on both the different sides, so you will have to connect it to another ground on Arduino board, but you can even connect it here. I just connected it the other way to make it look more good to you. Also, we'll connect one of the DC motors, so you can easily buy this at your store, and it works on DC current, DC input, and it is quite useful for small applications. And yeah, it can work on 5 volts. The direction doesn't really matter, you just have to wire either way. The spinning of the motor takes place accordingly. If you pass forward current, then the motor will spin clockwise, and if you supply reverse voltage, then it will spin counterclockwise. But there is no really specification required for our application, so we are just going to interface it the way I like. Okay, now that you have the wires, and you have the small holes on the input pins on the DC motor where you can supply this wire and sort of wind around it to make it look better, and also it will stay longer on there. I'm just having some problem with the wire. Let me just adjust it. Okay, yes, so now that we got the wire adjust, so what you'll do is take one end of the DC motor and connect it to the same input that we are getting, output, sorry, from the Arduino board, and connect the other wire to a ground, say this one, and some of these wires will be a bit difficult to push in the breadboard, especially when you are having new products, so don't worry about it, just try to make it work. Maybe you can wiggle it around, and let me just try once more. No, what's the problem? Let me try once more. Okay, yes, so we have got it connected. So yes, our hardware part is completed. We have successfully interfaced the sensor with the IC with the board with the Arduino, and Arduino with the output, which are LED and DC motor. I think it's very simple, and I hope that you can see the circuit in its entirety, and I think that you can easily interface the circuit without any sort of complex maneuvers. Yeah, so now what's left is implementing the code, and as we'll see next how we can make it run. Hello guys, so now the moment that you have been waiting for, the implementation. So we have successfully run the code, and you can use this platform Arduino IDE to upload this code, and we have modified the code a little bit to make it work. And yeah, so right now we have inserted the soil moisture sensor in this beautiful plant, and I have recently watered it, so the LED is currently uh, turned on. But let me just show you if what happens if I pull it out. So yeah, as you can see, the soil moisture sensor does not work in a non condition if it is not in the soil and water. I will try to also add a video with dry condition, but for now you can see we have implemented a basic switching mechanism, and by doing this you can easily control the watering system. Now this motor here, I originally intended to add it to the circuit, but seems like it runs on 9 volt power, and our Arduino board can only give like 5 volt at max, and even the current in the digital out pins, which are this, is like 20-25 milliampere. So we require much more current and also a very high voltage. So maybe in the next video I will try to implement the transistor as a switch mechanism to take power from your home in a single outlet, which is I guess 270 to 80 volt in the United States, and 230 in India. So yeah, as far as the basic implementation goes, we have successfully created this project, and I hope that you enjoyed doing this along with me. So that's all from me. See you soon.